In this video, I'm going to talk about the how to using the matriculation program statistical table. Okay, so mainly in this video, I'm going to talk about the binomial distribution table. So I'm straight to the point. I want to tell you how to using this statistical table. So if let's say you know that binomial is defined, right, to be having a number of sample and have a probability of success here, right? Okay, now I go for specific. If I have a binomial with a sample of 40 and the probability of success to be 0.45, right? 0.45. So if you want to find the probability by using statistical table, you always refer to the binomial distribution, because this is a binomial distribution, number of sample n and p. So very simple. So you go for the binomial distribution table, so which is table 1, right? All about table 1 for matriculation program. So table of binomial probabilities. So you search for the number of sample to be 40, right? Number of sample, n is 40, and the value of p will be 0.45. So number is 40, so we go for searching for the value. If you see that this will be 15, 0.02. If this value of n is 15, is 0.02, and this will become the column that I'm interested about. Okay, so now we go for 40. Okay, 40. This is the sample is 40, yet it's a 40, but 0.45 is not above here, right? There is no value of 0.45 here. It means this is not the page that I want to find. So I keep finding, alright? Keep finding. Then I see that there is a value of 0.45 here, right? Can you see that? 0.45. So now I go flipping the page. Okay, then I see 7, 8, right? I need 40, right? Number of sample to be 40. So what I'm going to do is I'm going to find for the page with the number of sample to be 40 here. Alright? Okay, let's see. So now you look at here. We have 40. N to be 40. And probability to 0.45. So this is the column that we are interested about. Can you see that? This is the column. You see that? 40. The number of sample is 40. Right? The numbers are 40. And the probability of success is 0.45. 40, 0.5. So this is the column that we're going to search for the value when we're finding the probability involving this distribution. So now, I'm going to tell you that our table, statistical table for binomial distribution is in this format, right? Is in this format, where is the px greater or equal r here. So what's the meaning here? For example, if I want to find the value of px at least 15, x at least 15, very simple. So you can read from this table with the value of 40, alright, 40, 0.45, right, 40, 0.45, and you're searching for the value here. Where is the value of 15? 15. So this is the value of 15, alright, 15. So if you see carefully, 15, so be careful, 40, 0.45, then you search for the value of 15. 15, so in this column, the value 15 correspond to 0.8674. 0.8674. So means that the answer for this will be 0.8674. Very simple. Alright, as long as it's in this format, the table here is in this format. So for example, if I want to find for px greater or equal 7, 7. So very simple. As long as it's in this format, x greater or equal r, we can straight away using the statistical table. 40, 0.45, 0.45. So where is the value? 7, right? 40, 0.45, 7. Where we go? 1, 3, 4, 5, 6, 7. Yes, this is the value. So which will be 0.9999. Alright? Means that at least 7 will be 0.9999. 99. Alright. If I say probability of at least 20, again, very simple. You can search from here. 40, 0.45, 20. Search for the value here. 20. Where is 20? Alright. 20. 0.3156. Okay. 0.3156. Okay. I hope you already understand this one. Okay. Now we go for the second part of this video. So how if I asking you to find the probability of same thing, the same distribution. Now I want to find the probability. Okay, so part B. So let's say if I want to find the probability of x greater than 19. As we know that if we want to using the statistical table, this statistical table, we have to follow the format of probability of x greater or equal r. This is the format, alright, for our matriculation program statistical table. So if you say that px greater than 19, alright, greater than 19, so you have to rewrite this because greater than 19 is at least 20 for a discrete random variable, right? It's at least 20. So okay, some students will ask me, sir, why is it at least 20? Because what it means by greater than 19, and you must know that x must be an integer. For this case here, it is a countable value. It's a discrete random variable. So more than 90 means 19 means 20, 21, 22, 23, so on and so far, right? Means start from 20. That's why I write as at least 20. Greater than 19 is at least 20. So then we can take the value, right, by looking at this distribution. 40, 0.45, right? 40, 0.45. So the value of 20, the value of 20 here will be 0.3156, right? 0.3156. So that's the answer. 0.3156, right? So C. Let's say if I want to find the value of px less or equal 13. Alright, listen to my working. Okay, try to see at my working. So if I have less or equal 13, I cannot using this statistical table before I modify. I cannot say 40, 0.45. Then I go for the value of 13 and I conclude that the answer is 0.9614. The answer is wrong. It's a mistake because this is in the form of less or equal. So remember, our statistical table must follow the format of px greater or equal r. So, and I need to convert this as this is what less or equal 13, right? So what is meant by less or equal 13? Means from 0, 1, 2, 3, 4, 5, 6 up to 13, right? X less or equal 13 means from 0 up to 13, right? From 0 up to 13. Less or equal can be 0, can be 1, can be 2, up to 13. So it means that then you know that you have 40 sample. The x value can be from 0, 1, 2, 3 up to 40, right? It will be start with 14, 15, 16, up to 40, right? The maximum x value that can be taken here will be 40. Minimum is 0. So they just want at most 13, means from 0 up to 13. Means that 14 onwards they don't want, right? So I have to take everything. As you know that the discrete random variable, this x is a binomial distribution. Binomial distribution is a discrete random variable. The total probability for each, you are getting 1. So that's why I'm taking 1 minus away probability of at least 14. I want the value from 0 up to 13, but I don't want 14 and above. This one is the one that not inside the box is something that I don't want. I cancel off 14 up to 40. It's at least 14. Another meaning here. So now I can using this I can find this from statistical table. because it's already in the format of Px at least R, right? Okay, 14. So with this column, 40, okay, 40, 0.45, 14, right? So where is the value of 14? Okay, 14, this value of 14 here, all right? This column, corresponding value 14, 9249, right? 9249. So 0.9249. If you subtract this with 0.9249, you are getting 0.0751. Alright, I will give you more example. Once you understand, you can stop the video and you try it as an exercise, right? So you don't have to follow everything, okay? So this is an advantage. I do more for you so that you can see the difference. So what in case now, okay, you can try this, alright? You can try. So what is the probability of x less than 20, right? You can pause the video and try this question here. So less than 20, you know that less than 20 is the value from 0, 1, 2, up to the value of 19. We said less than 20, kurang daripada 20. Less than 20 means the maximum will be 19 if this is an integer, right? It's a 0 up to 19. So we want 0 up to 19. As you know that the number of try in this case is 40 try. 40 try means it starts with 0 up to 40. 20, 21, so on and so far up to 40. Okay, you look at this. We cannot read this from a statistical table because our statistical table is in the format of greater or equal R, right? It's in the format of Px greater or equal R. So, okay. Now, everything here means that I just want a number here, 0 up to 19. So, I have to take 1 minus with probability of the one that not inside the box. Not inside the box, start with the value of 20, right? Start with the value of 20, at least 20, right? Saya hanya nak nilai yang kurang daripada 20, tidak termasuk 20. So it means 0 up to 19. So 20 and above, start from 20, that's why at least 20. So now it's already in the format followed by the in the statistical table. 20. So find for the value 20. So 40, 0.45, 20. So where is 20? 20. Be careful when you take the value. The value is 0.3156, right? 0.3156. 1 minus 0.3156. So if you calculate this, you are getting the value of 0.6844. Okay, as simple as that. Alright, okay, now I go for further examples, more examples so that you have better understanding. So, alright, now in case if a question asking you to find for the probability of x, probability of 9 between 9 and 14. We said this to be the value of x between 9 and 14. So how to using this? By using statistical table. Okay, so then you have to understand the concept, the format of Px greater or equal R here, right? Okay, doesn't matter. So before that, don't think about this. Think about what is the value between. Cannot be 9. Tak termasuk 9. There are no equal here. Not include 9 and 14. So you know the value will be between 9 and 14. It will be 10, 11, 12, 13, right? 10, 11, 12, 13. So I put this in a box, right? In a box. This is the value that I want. Saya letak dalam kotak. Ini adalah nilai yang saya perlukan di antara 9 dengan 14, iaitu 10, 11, 12, 13. Tidak termasuk 9 dan 14. So, but I know that start from 10, 11, 12, 13. There is still have value 14. Because why? Because the number of sample here is 40. Right? So the number of sample here is 40. So you know that it will be 40, 0.45. So the number of sample is 40. Maximum the X value can take up to 40. So means the 14, 15, if you list out, it will be up to 40, right? This is not a working, this is just for your understanding. So we want the value of 10 up to 13. We don't want 14 and above. We don't want 14 and above. Means that, in this case, we not start from 0. We start from 10. We want 10, we want the value of 10, 11, 12, 13. So means that it must be at least 10. From here, 10, 11, 12, 13, 14, 15, up to 40. All these things here, from 10 up to 40 is at least 10. Then you have to subtract away probability of X at least what? This is the most important value here. At least 14. We don't want 14. We don't want the value of 14 and above. So that's why we put 14 here. Alright? We want 10 up to 40. I minus the value of 14 up to 40. Right? 14 up to 40. Then I have the value of 10 up to 13. Right? Which is required by the question. So how to get the value here? So you can read from the statistical table, right? Same thing, okay? 40, 0.45. So where is the value of 10 here? The value of 10 here is 0.9973, right? 0.9973. At least 10. Minus away at least 14. Right? At least 14. So you find here 40, 0.45, at least 14. 14, 9249. 0.9249. So if you subtracted this value, you have 0.0724. As easy as that. So by now, I hope you already understand what is meant by using the statistical table. So okay, never mind. Okay, you can try more examples. For example, G. Now we have G as our examples. So G, let's say in case they want to find the probability more than 9, but at most 20. So before that, consider about the value in between here. Value in between here. So can it include 9? Can it include 9? No, it should not include 9 because it's a number greater than 9. So we start with 10. Start with 10. We start with 10. We not start with 0. Start with 10. We list out 11, 12, 13. Wow, there are many values. Up to 20. Up to 20. So this is the value required by the question. Nilai yang diperlukan, yaitu antara sini termasuk 20, equal. That's why we put 20 here. But we never put 9. Cannot be 9. So it's 10 up to 20. So, but you know that we only want 10 up to 20. But there is above here, there still is a value. Up to 40. Right? Up to 40. If this is up to, if the value here is, for example, 30. If this is 30, so the value here you need to list up to 30. Alright, in your mind, alright, you shouldn't write this, okay? Just for your understanding, 21 up to, now it's 21 up to 40, right? Up to 40. So, okay, 10 to 20, we just want 10 up to 20. So we start from what value? We look at here, start from inside the box here. Start from 10. Start from 10 up to 20, but we don't want 21 and above, right? We just want 20, but 21 and above we don't want. So we have to potong out this, so this becomes at least 21, because start from 21 and above we don't want, so that's why we minus. So okay, again using statistical table, 10, right? Okay, 40, right? 40. So 0.45, and then 10. Where is 10? 0.9973, right? 0.9973. 21. Okay, again, right? I repeat for you. Right? 40. 0.45. 21. Where is 21? 5, 0. Okay, 21. 0.2130. 0.2130. So you write here 0.2130. So just calculate the value, then you will get your required probability, which will be 0.7843. Right? Is already enough for you to understand. So never mind, I will give you more examples. Okay. So for example, now if I have 12x less than 18, pause the video now. Pause the video. Don't keep looking the video. It's not have any benefit for you. So alright, okay, now you see you have 12 and 18, right? 12 and 18. Between 12 and 18, include 12, right? Include 12 means start from 12. 13, 14, 15, ... Can it up to 18? Can it be up to 18? No, it's less than 18. The number before 18 will be 17. So I put in a box. Means that I want 12 up to 17, right? 12 up to 17. So 18 and above I don't want. 18, 19, I know it will be up to 40 because the binomial is distributed with total sample of 40, 0.45, right? So doesn't matter, this is in your mind, right? This shouldn't be your working, right? I just for teaching, so I list out for you. So we start from 12. Start from 12. Minus away at least 12. This is the value that start and not inside the box. I don't want 18 and up to 40. I just want up to 17, right? 18 and above I don't want. That's why I write here to be at least 18 here. Alright? If you read from the statistical table, alright, now I think you already know how to get the value. 9821 minus away 0.5609, right? How to get this value? So you can find from the statistical table 40, 0.45, so 12, right? 12. So you find for 12, 0.9821, right? 18, okay, 18, where's 18? 0.5609, okay, exactly. So then if you calculate, you are getting 0.4212, okay? So I think now you have better understanding already. Last example for you, right? Last example for you. So in case I give all the positive for you so that you don't have you have many reference. So now if let's say they're asking for probability of between 15 and 20, sama saja ba. Okay, so you just take 15. See, can include 15, you know, between these two value, okay, can include 15, right? 16, 17, 18, 19, 20. Okay lah, this one not many, I list out everything. Okay. Sir, why now can be 15 and 20? That is equal here, right? It's 15 up to 20. So you know that the sample here is 21, 22, 23, up to 40, right? Up to 40, so many. So okay, doesn't matter. Start from 15. I want 15. I want 15. But I minus away something that I don't want. I don't want something that not inside the box, which start with the value of 21, right? So from statistical table, find the value of 15. Okay, 40, 0.45, 15. Where is 15? 0.8645. 0.8674 minus away at least 21. At least 21. Where is at least 21? 0.213, right? 0.213. If you calculate, you will have the value of 6544. As simple as that. So before you study all my examples in my lecture notes, you don't skip this video. Alright, this video teach you how to using the statistical table for binomial distribution. Right, that's all for this video. Hope you understand.